For years, AI in the financial world felt like a big experiment. Lots of interesting pilots, a ton of promising tech, but there was always this question mark hanging over it. Well, that question mark is basically gone. Today, we're seeing a really clear line from those early projects to straight-up profit. So let's dive into how the financial industry is pulling it off.
So what happens when 89% of an entire industry, a massive industry like finance, agrees that a single technology is making them money? And I don't just mean saving them money, I mean actively bringing in new revenue. It means the revolution isn't coming, it's already here.
All right, so here's our game plan for this explainer. We're going to start with the hard proof of AI's profitability. Then, we'll look at the open source engine that's really fueling all this growth. After that, we'll see how all this success is leading to even bigger investments. And finally, we'll get a peek into the future with the rise of something called AI agents.
Okay, let's jump right into our first section. Proof is in the profit. Seriously, this isn't about hype anymore. We're talking hard numbers, tangible results, and it's completely reshaping the world of finance.
This right here gets to the heart of that 89% number we just saw. And the most important word on this screen, it's and. This isn't a trade-off, it's not one or the other. Almost 9 out of 10 firms are seeing AI boost their revenue and shrink their costs all at the same time. I mean, that's the holy grail in business, and AI is actually delivering it.
So how big is this growth we're talking about? Well, take a look. A massive 64%. That's almost 2/3 of the entire industry are seeing revenue jump by more than 5%. And for almost 1/3 of them, that growth is hitting double digits, all thanks to AI.
And on the flip side, AI is just crushing it when it comes to efficiency. As you can see here, over 60% of firms have cut their costs by more than 5%. And get this, for a full quarter of the industry, those savings are over 10%. These are the kinds of numbers that get entire boardrooms very, very excited.
Okay, but how does this actually work in the real world? This quote from Dwayne Jeffrey gives us a perfect example. He's talking about payment operations, where an AI can figure out the absolute best network to route a transaction through, and it does it in milliseconds. Every tiny little improvement, every basis point, which is just 1/100th of a percent, goes directly to the bottom line as revenue. It's not abstract theory, it's operational magic.
So, this kind of incredible ROI doesn't just happen by magic, right? It's being driven by a very specific tech strategy. Let's move on to our second section and see how flexibility is the real fuel for this growth, the open source engine.
Get ready for this number, 84%. A staggering 84% of financial organizations say that open source is a critical part of their AI strategy. This isn't some niche trend, folks. This is the mainstream. This is the engine under the hood for pretty much the whole industry.
Now, before we go any further, let's make sure we're on the same page. What exactly are open source models? Well, think of them like this. They're super powerful AI foundations, but their blueprints are public. This means any company can grab them, tweak them, customize them, and train them on their own private data without being totally locked into one single tech provider.
Okay, this slide is super important because it really lays out the strategic choice these firms are making. On the one hand, you've got open source, total flexibility, no vendor lock-in. Awesome. But on the other hand, proprietary models, the closed-off ones, can sometimes give you better performance for really specific niche tasks. And as Alexandra Musaviza points out, the real winners here aren't just choosing one or the other. The smart ones are becoming experts at knowing when to use which tool for the right job.
All right, let's recap for a second. We've established that AI is making real money, and the industry has a flexible, open source strategy to make it happen. So what's the logical next step? You guessed it, you double down. Welcome to Section 3, Investing in What Works.
This is about as close to unanimous vote as you will ever see in the business world. The ROI is proven. It's not a theory anymore. So now almost every single financial firm is either pumping more money into their AI budget or at the very least keeping it the same. The experiment is officially over. This is a core part of the business now.
So where's all this cash going?
Well, it's actually a really smart, balanced strategy. The biggest slice of the pie, 41%, is going toward making their current AI systems even better. That's followed closely by 34% for finding totally new ways to use AI, and 30% for just building out the rock-solid infrastructure to support it all. It's a really intelligent way to scale up.
And that brings us to our final section. And honestly, this is where things get really interesting. If everything we've talked about so far is the present, this is a look at the very, very near future. Let's talk about the rise of AI agents.
So what's the big deal with an AI agent? What makes it so different? Well, the magic word here is autonomously. These aren't just tools that answer one question you type in. An AI agent can understand a big, high-level goal, figure out all the steps it needs to take to get there, create a plan, and then go and do it. It's a massive leap forward.
And you might be thinking, okay, this sounds cool, but it's probably years away, right? Wrong. Check this out. Over 20% of firms have already deployed AI agents. Another 22% are planning to roll them out within the next year. You add that up and you're looking at over 40% of the industry that's either using this tech today or will be in the next 12 months. The momentum is just undeniable.
So, after all of that, what's the one thing you should walk away with? This quote from Helen Yu just nails it. Everyone has access to these powerful open source models now. That's leveling the playing field. The technology itself is becoming a commodity. The real long-term advantage, the secret sauce, is a company's own unique proprietary data.
And that really leaves us with this final, massive idea to chew on. For centuries, a bank's power was all about how much capital it had in the vault. But in this new era, as we've just seen, the real power is the ability to turn information into profit. So it makes you wonder, what's a bank's biggest asset today? Its money or its data?
So what if an AI could look at a picture, not just as one big image, but as a collection of different things it could actually name and describe and even edit, all just by using words? Well, today we're diving into a really cool breakthrough that does just that. It's teaching AI to see the world pixel by perfect pixel using a language it already knows inside and out, words. Okay, let's just jump right in and see what this thing can actually do. On the right, you've got an AI telling a story about a person on a motorcycle. Pretty standard stuff. But look at the left. That's where the magic is. See how parts of the story are highlighted? Well, each of those highlights matches up with a specific colored outline in the picture. The AI isn't just saying there's a rider, it's showing you exactly where the rider is, right down to the pixels. Same for the bike, the background, everything. And that leads us to the big question, right? How on earth is this possible? How can an AI connect a word, like rider, to a super specific group of thousands of pixels on a screen? I mean, this has been one of the toughest nuts to crack in artificial intelligence for a long, long time. To really appreciate why this is such a giant leap, we've got to understand the problem that researchers have been banging their heads against for years. It's this pixel-perfect problem that AI has always had.
You know, for the longest time, just getting an AI to say cat when it saw a picture of a cat was a huge deal. But teaching it to understand the cat's left ear or the tip of its tail, that was a whole other ballgame. It meant writing tons of messy, specialized code, and it was just so inefficient.
And this really lays it all out. The old way, over on the left, it was like using a giant, clunky, complicated machine. You needed special models, complex code. It could take hundreds of digital tokens just to describe a single shape. But the new way, the SAMTok way on the right, it's so much simpler it's almost funny. The solution? Just add new words. So, how did this team from ByteDance and Wuhan University actually pull this off? Well, they didn't just try to fix the old, clunky machine. They threw it out and built something totally new. You could say they taught the AI a brand new language for seeing. Okay, so here's a key idea you gotta get. For an AI, a specific part of an image is called a mask. You can see one here. It's basically a super precise map that says these exact pixels belong to the person and these don't. It's incredibly detailed, but it's also a ton of complex data for an AI to process. And here is the absolute magic trick. A new model called SAMTok can take that entire complicated map of pixels, that mask, and basically shrink all of that information down into just two special words. That's it. And this whole process has a name. Mask tokenization. It's the engine that's doing all the work. It turns any shape, doesn't matter how weird or complex it is, into a simple two-word name. This means the language model can now understand a visual shape as easily as it understands the word apple.
So how does this all come together into a working system? Well, it builds into this really elegant and powerful loop. It's not just about the AI understanding what it sees, it's about creating a true two-way conversation between the world of pixels and the world of words. And it works in 3 simple steps. First, it encodes a mask, turning it into a unique digital fingerprint. Then it tokenizes that fingerprint. It looks through its dictionary and finds the 2 special words that are a perfect match. And finally, and this part is key, it can decode. It can take those same 2 words and perfectly rebuild the original mask.
It's basically a universal translator between pictures and text.
And this diagram just shows it all beautifully. A normal language model can now use these special mask words to understand a region you point out, or it can generate its own mask words to show you what it's talking about. It's this single, clean interface for both reading and writing these pixel-perfect shapes.
So, what's the big payoff for creating this cool new language? Is it just a neat trick? Not at all. The results are actually a huge boost to the AI skills across the board.
The researchers took this SAMTok system and plugged it into a really powerful vision language model. They trained it on about 5 million images that were all set up with these new mask words. And the model they created, called Quen VL SAMTok, just started crushing it, getting top-of-the-line, state-of-the-art results on all sorts of difficult visual tests.
Okay, let's look at the actual numbers for that conversation task we saw at the very beginning. Look at AP 50. That's basically a score for how accurate the masks are. The SAMTok model jumped from 33.2 all the way up to 38.5. That's a big deal. Now look at SideAir. That measures how good the written descriptions are. It went from 49.5 to 55.0. These are not small improvements, folks. The model is way more accurate and it's a much better writer.
But wait, there's another huge benefit here. Because the masks are now just words, it gets way easier to train the AI to be better. You can use a method called reinforcement learning. Think of it like training a dog. You just give the AI a treat, a reward, for getting the right words for a mask. This is so much more efficient than the old way of trying to reward it for getting thousands of different pixels just right.
And you can literally see the difference it makes. On the left, that's the model with just the standard training. On the right, that's the same model after reinforcement learning. Just look at how much better it is at finding all the objects it's supposed to, in this case the glasses on the table, and how much cleaner and more accurate the masks are. It's a night and day difference.
So, what does this all mean for us? Why should we care that an AI can see in words? Well, this whole approach unlocks a completely new and frankly more natural way for us to interact with all our technology.
The researchers who wrote the paper said it perfectly. They called it a scalable, unified, and language-native paradigm. And that phrase, language native, that's everything. We're finally getting computers to see the world not in their language of pixels, but in a way that makes sense with how we humans actually talk about things.
And this just opens the door to stuff that feels like science fiction. You know, imagine a photo editor where you just say, hey, make that person's shirt blue. Or a robot that knows exactly which screwdriver you're pointing at in a messy toolbox. Or even a medical AI that can highlight the exact cells a doctor is describing in a scan. The possibilities here are just huge.
In the end, what SAMTok does is really profound. It takes a really hard vision problem and it cleverly turns it into a language problem. And since we've gotten so incredibly good at solving language problems with AI, well, that just opens up a whole new universe of things we can do. It really just leaves you with one exciting question. Now that AI can see in words, what are we going to teach it to do next?
Hey there, and welcome. Today, we're going to talk about something, well, it's fun, it's fascinating, and it's actually a pretty smart move from Google. We're talking about a new feature that's all about turning your photos into the next big thing online. I mean, come on, let's be real. Who hasn't had that thought? You're scrolling, you see a perfect meme, and you just think, you know what? My face would be perfect for that. It's that urge, right? To jump right into the joke with everyone else.
Well, it looks like Google has been paying attention. They've just dropped a brand new tool right inside Google Photos that's designed to do, well, exactly that.
Okay, so what is this thing? This meme machine from Google? Let's get into what it is and, what's under the hood. So the official name is Meme. And yeah, as you can see, it's an experimental feature. It uses generative AI to kind of smush your pictures together with classic meme templates. But here's the key thing to get. This isn't just a simple copy-paste job. Oh no, the AI is actually generating a totally new image from scratch based on your photo. Pretty wild, right?
And what's really cool is, this thing didn't just pop up overnight. A tech blogger, Assembled Debug, actually caught a glimpse of it being built way back in October. So for the real tech heads out there, this has been on the radar for a while. A lot of people have been waiting for this. All right, let's hit the key details real quick. First off, Google is making it very clear this is an experimental feature. The brains behind it? That's their Gemini AI, specifically a version they're calling Nano Banana. Right now, it's a US-only thing, but the good news is it's coming to both iOS and Android.
Okay, so you've got the app, you live in the US, and you're ready to become a legend of the internet. So how does it actually work? Let's walk through it.
You'll be happy to hear it's super simple. You just pop open the Google Photos app, find the Create tab, pick a template that speaks to you, grab one of your own pictures, and tap Generate. That's it. The AI handles the rest.
So after the AI does its thing, you get a few choices. You can save your new masterpiece, obviously. You can share it straight to your social feeds, or, and this is a big one for an experimental tool, if the first try is kind of meh, you can just hit Regenerate and have it take another crack at it. And hey, here's a little pro tip, straight from Google themselves. If you want the best results, you got to give the AI good material to work with. We're talking well-lit photos, pictures that are in focus, and where you're looking more or less at the camera. It's simple, really. The better the photo you give it, the better the meme you're going to get.
All right, so we get the how, but what about the why? I mean, let's be real. A company like Google doesn't just release a fun little feature for kicks. There's always a strategy, and this is no exception.
And this really breaks it down perfectly. You've got two sides to this coin. For you and me, the user, it's easy. We just want to have fun, make something funny, and share it with our friends. But for Google, their goal is a bit different. They want to keep you in the Google Photos app, and they want to show off just how powerful their Gemini AI is in a way that's, well, fun and easy to understand.
And don't get it twisted. This isn't happening in a bubble. This is absolutely a move in the giant AI race that's going on. You've got competitors like OpenAI blowing people's minds with tools like Sora for video. So Google has to keep putting out its own cool, creative AI features for everyday people. It's how they stay in the game, how they stay part of the conversation.
So yeah, Meme might seem like just a toy, right? But it's actually playing a really serious role in Google's grand plan. Let's dig into why this is so much more than just a passing fad. And this timeline really tells the story. I mean, it was spotted months ago while it was still being built. Then we got the official announcement, and now it's rolling out. This wasn't a whim. This shows a very deliberate, planned-out strategy for what looks like, just a silly little feature. It's a calculated chess move.
And here's the bottom line. These unserious, fun features are fantastic at keeping you hooked. Why? Because they're personal. They're easy to share. They're sticky. Think about it. Every minute you spend messing around in Google Photos making a meme, that's one less minute you're trying out a competitor's AI tool. But it's even deeper than that. It's training your brain to connect AI with Google. It's a fight for your daily habits.
Google's also being pretty straight with us about it. They're managing expectations, saying, hey, the pictures it spits out might not be a perfect one-to-one match with your photo. And that little admission, acknowledging that little bit of AI weirdness, that actually opens the door to a much bigger idea.
Right now, it's usually pretty easy to spot the mistakes, right? The glitches. But what happens when these tools get better and better and better? When they get so good at seamlessly editing our faces, our photos, our reality, that it raises a huge question. What happens when we can't tell what's real and what's just a meme anymore? Something to think about. Thanks for tuning in.
In the world of AI, we always hear that more data means more power. And sure, that's usually true. But what happens when you have way too much data? Today we're diving into a really cool algorithm from Google Research called GIST. It's designed to solve that exact problem by picking the perfect, bite-sized sample from a dataset that's just too big to handle.
So here's our game plan. First up, we'll get a handle on the massive data challenge that AI is up against. Then, we'll look at this constant tug-of-war in data selection, this idea of diversity versus utility. After that, we'll introduce GIST as the solution, see how it actually works its magic, check out the results, and finally, take a peek at what this means for the future of smart data.
All right, so let's jump right into the problem itself. Because, to really get why GIST is so smart, you first have to appreciate the enormous scale of the challenge that modern AI models are facing every single day.
And that really brings us to this central question. I mean, think about it. Today's machine learning models have access to these gigantic, incredibly complex datasets. Trying to use all of that data to train a model? It's just not practical. It would be way too slow and cost a fortune. So you can't just throw everything at it and hope for the best.
The strategy, then, is something called subset selection. The whole idea is to intelligently pick a smaller but still representative sample from that giant pool of data. But that's the million-dollar question, right? How can you be sure that the tiny little piece you picked has all the right information to train a really accurate model?
And this is where things get super tricky. See, just picking a smaller set isn't good enough, because right away, you slam into this fundamental conflict about what even makes a data point good in the first place.
Okay, so on one hand, you've got data diversity. This is all about avoiding redundant information.
You want broad coverage, right? You don't need 100 nearly identical pictures of the same cute cat. But on the other hand, you have data utility. This is about picking the most informative, the most useful data points for whatever you're trying to teach the AI to do.
And this creates a huge dilemma. If you go all in on diversity, you might end up with a bunch of unique data points that are, well, totally useless. But if you focus only on utility, you could just get a tight little cluster of really similar redundant examples. What you need is both, but they're constantly pulling in opposite directions.
It turns out that finding that perfect balance between these two goals is what's known in computer science as an NP-hard problem. And all you really need to know about that is that it's in a class of the hardest computational puzzles out there. Finding the absolute 100% perfect answer for a massive dataset is, for all practical purposes, impossible.
So how do you solve an impossible problem? Well, you get clever. Let's introduce the hero of our story, GIST. It's a brand new algorithm that was presented at a major AI conference, and it was designed specifically to tackle this exact challenge.
Now, GIST stands for Greedy Independent Set Thresholding. It's a bit of a mouthful, but its goal is actually really simple and powerful: to find a high-quality data subset that manages to maximize both diversity and utility at the same time. It's all about tackling both sides of that dilemma we were just talking about.
So how in the world does GIST actually pull this off? Well, instead of trying to solve the entire impossible problem all at once, it does something really smart. It breaks it down into a much more manageable two-step process.
Okay, here's how it works. First, it sets a rule for diversity. It basically says, okay, let's decide on a minimum distance between any two data points we pick. They can't be too similar. Then, once that rule is locked in, it moves to step 2. Find the most valuable, the highest utility set of points that doesn't break that distance rule.
This whole process actually transforms the problem into something called the maximum independent set problem. And the dinner party analogy they use is just perfect for this. Imagine you're planning a party, but some of your guests just can't stand each other and can't be in the same room. Your goal is to invite the most interesting, fun group of people you can, while still following that no conflict rule. It's a massive puzzle, right?
And here's the really brilliant part. GIST uses what you can basically think of as a tuning knob for that diversity rule. It just systematically tries out a whole bunch of different spacing requirements. And for each setting on that knob, it greedily grabs the most valuable data points it can find. By doing this over and over, it starts to zero in on that perfect sweet spot, the ideal balance between value and variety.
So a clever method is one thing, but the real power of GIST comes from its provable guarantees and, how it actually performs in the real world. This isn't just a cool idea, it really works.
And this is where GIST is a total game changer. It comes with a mathematical safety net. It's actually the first algorithm of its kind to have a provable guarantee. What that means, in simple terms, is that it's mathematically proven to find a data subset that gives you at least half the value of the absolute, theoretically perfect solution, a solution that, by the way, is literally impossible to calculate.
And that theory translates directly into amazing real-world results. Just look at this chart from experiments on the massive ImageNet dataset. You can see pretty clearly that methods that were enhanced by GIST consistently produced more accurate models than the standard techniques, like just picking data randomly.
So what are these GIST-enhanced methods? Well, take GIST margin. It uses a popular strategy of picking confusing data points to help the model learn tough cases. But what GIST adds is a strict rule. You can't pick two confusing examples that are too similar to each other. So GIST basically takes these already good strategies and just makes them way smarter and more efficient.
Okay, so let's zoom out for a second. What does an algorithm like this really mean for the future of AI? This is about more than just one little trick. It's about building a whole new foundation for how we work with data.
One of the most critical things here is speed. I mean, despite the insane complexity of the problem it's solving, the actual process of picking the data with GIST is incredibly fast. We're talking a tiny fraction of the time compared to the days it can take to actually train the final model. That's what makes it a truly practical tool for real-world AI.
The researchers from Google really summed it up perfectly. By breaking down this huge diversity versus utility puzzle, GIST gives the whole AI community a tool that is provably effective. As they said, the gist of it is, GIST ensures we're sampling data intelligently.
So yeah, this research lays down a really powerful foundation for the next generation of AI that can truly scale. It gives us a guarantee. As our data sets keep exploding in size, we'll actually have the tools to train our models on samples that are both super informative and not full of junk. Which, of course, leaves us with one last big question. As data keeps growing, what's the next impossible problem we're going to have to solve?